Hello everyone. Today we will be discussing the simple sum problem of November 2015 long challenge. That is the third problem. In this problem, we were given n, and we were supposed to calculate this straightforward function, that is n by GCD of I comma n, where I is from 1 to n, summation of this. So if you follow a naive approach, then you won't be able to pass even this first subtask also. So we are supposed to calculate the value with some other logic, and if you have read the editorial, then you will notice that they were not supposing us to know the formula, and they were expecting us to use the Google search engine to search for this formula, and it was very easier as easier to find the link. So the problem was not to find the formula, but how to implement this formula. So I won't be discussing the formula. Let's understand how to apply this formula. So what is this formula? P raised to 2e plus 1 upon p plus 1, where p is the prime factors of n and e is the power of that prime factor. Now what is prime factor? For 2, prime factor is 2, right? All the prime numbers which divide the number. So let's take 6, it is 2 comma 3, that is if we multiply both of them we would get 6. For 10 it is 2 comma 5, because we multiply by both of them we will get 10. And 4, let's take 4, it is having prime factor as 2, because if we multiply 2 twice we will get 4. So these are the prime factors. So for every p, yeah, let's take n equal to 10. So the values of p are prime factors are 2 and 5. So here p is 2 and 5. For 2, the value of e here is the power. Now 10 is obtained by multiplying 2 raised to 1 into 5 raised to 1, right? So raised to power is 1. So here e is 1 for 2 and 5. But let's take 4. 4 is having 2 raised to 2. For that it would be having p as 2 and e is also having 2. So so let's understand the code. In this code we are supposed to use some advanced method to calculate the prime factors, because the naive approach won't give you points. So we are using this sieve method. What is this sieve method? Let's understand. The sieve method is in short giving us this array, that is for index 2 it's giving 2, for index 3 it is giving 3, for index 10 it is giving 2. That is, for every number it is giving the smallest prime factor. So this function is performing is giving us that array. So let's understand how we are performing the operations. It is clear that all the even number would be having its smallest prime factor as 2, right? For 10 it is 2, 8 it is 2, 6 it is 2. So for all even number it is 2, and for all other numbers we would go from lowest number up till 10 raised to 7, and if that number is not set, so after setting all the even number we would go here. 3 is not set yet, right? So we would that means that that number is a prime number, so we would copy that index as the value itself. Now we would use that value and store all its multiple index values as the same value, that is for all. Now all the multiple, that is 3, 6, 9, we would set it as 3, but 6 is already set to 2, right? So we won't set it to 3 again. So for 9 it is not set, so we would set it to 3. Now we would take 4. 4 is previously set due to 2, right? Now 5 is not set, that is it is a prime number. So we would copy this value as it is, and we would copy that value to all its multiple indexes also, that is 5, 10, 15, 20. But all this index, but 10 is already set to 2, right? So we won't copy it. We are just finding this array. So we would follow these steps to get the array. So after performing the sieve function, we are scanning t, and then inside that scanning I, the number whose value is to be calculated, and then we are checking this condition, that is LP of I equal to I. That is if that number is a odd number, then we are just calculating answer as directly as by this formula. We would be discussing this formula later. Now let's go inside the else part. And else, if that number is not an prime number, we are calculating some values and then we are printing the answer. Now let's understand what we are performing here. Let's take n equal to 5. So we would check the value at index 10. So the value is 2 right here. So we would divide n by 2 until n is not divisible by 2. So we would divide it by 2, we would get 5, and we are using 2, and since we have divided once, so the power is 1. Now it is not divisible by 2, right? So we would take the next number, 5. Now let's take another number, that it is index 5, right? So we would check index 5, it is 5. So we would divide by 5, we would get 1, and we are using 5 and the power is 1. We have divided once, so we have reached n equal to 1. So we have to stop this. So for reaching from n equal to some value to n equal to 1, whatever divisions are taken place, we are using them to calculate the answer. So here it is 2 raised to 1 and 5 raised to 1, that is p. This is p, and this is p, and this is e in our formula. So for every p we are calculating this value and then multiplying them, that is we are calculating the function for p and e for this value and then for this value, and then multiplying them. So for calculating the for using that formula that is given to us, we are using this function, that is your LPI is the value of p and count is e. Now for our case, for n equal to 10, it would be this function would be called twice. For once it would send parameters as 2, 1, and second time it would pass parameters 5, 1. So here we are using this formula in our function. Now this formula looks different than the one which is given to us. We have given this formula, right? p raised to 2e plus 1 upon p plus 1. But this formula, if you follow this formula, then you would get wrong answer in two test cases, I think. So whenever this case happens, when your solution is right, still you are getting wrong answer, it means that there must be a overflow. So whenever overflow is happening, then you have to reconsider all the part of code where you are finding some big values. Here we are calculating some big calculation, so uh, we have to uh, use another simplified expression. So I am using this one. If you uh, expand this expression, then you will get the same expression as that given to us. This one is used just to avoid the overflow, and after calculating for every prime factor, we are just multiplying it to the answer and printing the final answer. Now let's look at this formula, that is when the number is prime number. So whenever it is prime number, we are not using the generalized formula. Instead we are using one which is simpler. But if you see carefully, this one is the same as this formula. Whenever this case happens, that is, the power would be 1, right, for this case. So that is in our formula, this formula, it is I equal to 1. So x square minus, it would be x square minus 1 upon x square minus 1. So this entire part would get cancelled up, so we would get the same answer.